Remembering the sequence of orbitals, 1s, 2s, 2p, 3s, and so on is very important. The first orbital only has one, the first energy level 1 only has one orbital. The second has 2, s and p. The third has s, p, and d. And the fourth you only have to know up to the 4p. Remembering that 4s and 3d, 4s fills first. So when you look at chlorine, it has 17 electrons. And with a negative, that means it's +1, so it's got 18. So if you kind of fill up the orbitals like this, and then start to think about what you're going to do. So that's going to be 18, so that's 2, 4, 10, 12, 18. So that means the rest of these you don't actually need, so that's that one done. Okay, now arsenic has atomic number of 33, so that means you've got to fill it with 33 electrons. And again, once you know this kind of order or sequence of orbitals, you should be fine. So that's going to be 2, 2, and 6. So that's 10, 12, 18, 20, because 4s fills first, 30, because going to use all of those, and 3 for the 4p3. Now, this is 26, but because it's Fe3+, you're going to end up with 3 less electrons at 23. But what I'm going to do first is fill up the 4s first, which is going to be 2, 2, 6, 8, 10, 12, 18, 26. Now, if I was going to get rid of 3, 4s empties first. So this one empties first here. So that means this one's going to be gone. But I've only removed 2 electrons, so I need to take one from the 3d. So that becomes 3d5. Now also remember that chromium and copper are exceptions you're expected to know. That's going to end up being 4s1, 3d5. I know this isn't in the questions, and this will end up being 4s1, 3d10. Okay, and those are exceptions you expect to know, because normally you'd have written that 4s2, 3d6, sorry, 3d4, and this one 4s2, 3d9. So making that 10 and 5 are the exceptions you need to know. Now, of course, ionization energy, that's just a definition you need to remember, so just make sure you get that. And the key of that, of course, is you're removing an electron and it's from 1 mole in a gaseous state. Okay, now ionization equations are only about removing 1 electron, and as this is the first ionization energy, we were talking about removing the first electron. So it'll go to Fe+, notice we're in gaseous states, plus an electron. If there was now there is an energy associated with that, and that would usually go next to it, and that would be some thermic value, some positive value for that, because it always takes energy to remove an electron. Okay, electronegativity is another definition you just must know, and it's the attraction an atom has for electrons in a covalent bond. You can use the word shared bond, that's equally valid, but it must be the covalent or a shared bond, or it's not going to be right. Now, this trend is going across a period, so the key things to talk about that is normally you'd have given this definition above about electronegativity. If you haven't, you must do it in your answer. So you can state what the trend is, which is, as you go across the period, the electronegativity increases. Now, it does this because as you go across, you must make some statements. For instance, the number of protons increases, and you can put in there that's the same as nuclear charge. It's not a bad idea. It's supposed to be charge increases, and also that they are in the same energy level, and that also means that the electron shielding is going to be the same. And this is all leading to you making a statement about the attraction. Therefore, the attraction is greater. And so the attraction for shared electrons will be greater as you go across. Okay, as you go across the period, it's going to be greater. Now, carrying on from that is just another trend question. So carbon and silicon. So carbon is in one group and silicon is in the group lower down. So this is going down the group kind of question. So you'll need to be talking about that. So as you go down the group, from carbon to silicon, the radius increases. Now the statements you'll need to be making are kind of similar in a way. The first will be silicon has more protons than carbon, which does increase the attraction. However, it is in a higher energy level, and as soon as that happens, the electron shielding is going to be greater. So you talk about that, and you're going to link this to distance, which is a huge one. You must talk about that. And so the distance increases. Once again, this is linking to attraction, so you need to say that. Therefore, the attraction decreases. And so the outer electrons are less tightly held, and the radius is bigger. Okay. There's only so much they can ask on these trends, so make sure you get it right.